Okay, then today we can discuss about the exercise 4. I will start from exercise 4. How we can do a integrated site suitability for disaster shelter. So in this specific study, what we are planning to do is we need to find out a suitable location for multi-purpose disaster shelter in Ratnapura district. Just imagine if there's like landslide or flooding happened, all of a sudden we need to find some places where we can accommodate helicopters and like the navy and the army personnel, and then we can like accommodate the people who were stressed due to this disaster. So both for this one we need to go with the buffer. We will go with the buffers. So we will use main road. So it should be near to the main road within like 200 meters range, and then at least 1 kilometer away from previous any landslide sites, and then overall constraint like slope, it should be less than 5 degrees to allow a helicopter landing or something like that. And then even the land use classification must like the purpose of the land should be either a bare land or a scrub. And then for this partial joint, then we will consider, okay, after filtering the sites, we will consider which GND divisions needs the most attention based on the vulnerability index. Here we will consider the vulnerability index as uh, the density of the population for your easy case. So let me share you the practice 4. This will be the complete workflow that we have to follow up. Before that, I will go ahead and like open up arc map. Same thing, you can download the dataset from there in the link provided. I already provided the link in the group and even in the description of this video. From there, you can download the dataset. Now I'm not going to repeat that part. You can download the dataset and then you can save the dataset in your working directory or somewhere. So now I will go ahead and like these are the datasets. So you can download it from there in the Google Drive, the provided link. So all the dataset is there for practical 1, 2, 3, and 4. You can download it from there. For practical 4, we need classification data. So here we do have the classification layer file, and then we do have DEM file to calculate the slope, and then we do have district shape file, then GND file, and then landslide location which were previously occurred, and then roads, and then Ratnapura district population. So same thing, after opening up the ArcMap, I will create a new folder, new blank document, and then I will set up my default geodatabase. You guys know what to do next. Then we need to create the default database. Instead of using the ArcGIS default database, we will create a geodatabase specifically for this project. Okay, let me link the folder into that specific directory. It's in D, CMVA 40 practical session 4. Okay, so there now in here I will create a new database as track 04, and then I will select this one as my default geodatabase and click OK. After that, I need to save the project. I will click on save as, and then select the same exact location, track 4. Here I will type track 04.mxd. So now what do I have over there? I do have the data files and then my project file and the geodatabase file. So here I do have the geodatabase file, and then here I have the project file. Now let's go ahead and like load up the data. Now you know how we can load the data. Go to the Windows, click on catalog. From there, go to the home directory. From there you can see all the locations and the data files are stored in here. So now I will start loading the data. Before loading the data, I will go with the procedure. So first what we need to do is we need to go and like calculate the population density, which I have already discussed this one earlier, how we can calculate the population density. So you guys know how we can calculate the population density. So how we can calculate the population density? Same thing, I will drag and drop the population file over there, and then I will drag and drop the gram Niladhari shape file. Now I will right click and export display XY, and then I will click display XY and then click OK. After that it will create this grid file. Now what I have to do is I have to select the gram Niladhari districts in Ratnapura district. So here the admin2 name is the district file. So from there I will select and then select by the attribute, then admin adm2 dash name, then equals get unique values. From there I will click Ratnapura and then click apply. So now you will see all the GND files which were located in Ratnapura district has been selected, and I can click apply and then click close. Now what I have to do is go into the search for clip, and then click on the analysis and then input feature Niladhari, and then the clipping feature should also be Niladhari. And then this one will be Niladhari clipped, or I can type Ratnapura DND and then click OK. It will take a while for the clipping to finish. Okay, now it has been clipped, so I will remove this file. So now next what I have to do is I need to get the population for this specific GNDs. So I discuss what was the procedure that we have to do. We have to go with the partial join. So we can search for the tool partial join, partial join under the analysis, and then for the targeted feature it will be Ratnapura GND, and then we are going to join the population of the from this data set. So Ratnapura GND, I will type dash, then the relationship should be like 1 to 1, and then in here population field I have to select it as merge rule sum. So we need to sum up all the point values of the population field, and then match option should be completely contains, and then I can click OK. So after that what should I see in this Ratnapura GND file? Just give me an error was there. Let me go there and check. I'm not found in this collection. Let me go and click on partial join again. This should be like targeted feature should be Ratnapura GND, and then join feature should be population CSV events, and then this one should be underscore POP join one to many population field, completely contains a joule sum okay. So just give me there Ratnapura GND population CSV, then GND pop 1 is equal 1 too many, and then population double merge rule sum, then this one should be completely contains, click OK. Please give me an error. So Ratnapura GND population events 1 merge rule sum, completely contains, OK. Read the data set first, quick analysis, population CSV for the Ratnapura GND, population clip, OK. Now this population file now join partial join Ratnapura GND population clip. Population role should be sum. Okay, done. Now I do have this layer. Rename this layer as. Okay, let me go to the catalog from there. If I open up the database file, I do have these files. Let me delete these. Now let me go to this partial join again for one last time. Ratnapura GND join features will be population clip and then one to one. Here the population field should be merge rule should be sum and then should be completely contains, and then the output layer I will type as GND pop and click. So now I will remove these two other layers. I don't need this one. So now what I need is this layer. We go into the attribute table. From there I will see the population data is in here. So now what we need to do is we need to do the projection. So before the calculation of the area, we need to do the population, because how we can calculate the density? Density is equal total population divided by the area of the specific GND. To calculate planar region, so we need to convert this GCS into a projected coordinate system. So how we can do the projection? We need to search for the tool called project. So from there, under the project data management tool, we can select the current layer Ratnapura GND population, and this one will be population projected, and then output coordinate system I can search for from the projected coordinate system, national grids, Asia, Kandavala, Sri Lanka grid, and click OK. And then you can click OK. And now the layer has been converted into the Kandavala. So from here you can see we do have a small deviation when you convert the coordinate system. Since Sri Lanka is like in between the equator, we don't see any major difference. But if you go into the North Pole or South Pole, like the countries in these two regions, you will see a huge deviation in the map. So now I will remove this file, and now I will open the attribute table of this file. Now I will create one field to calculate the shape area. So I will click here, and then from there I will say first I need to create the field. I will click on this table options and then click on add fields. From there I will say area GND area short integer. Instead of short integer it should be double, because area can be point data. So now I will go into the GND area, right click, calculate geometry, yes, area, it should be the square kilometers, and click OK and click yes. So now we need another field. We do have the area files. We will create another field. This one will be pop density, or in this case we will consider the population density as the vulnerability index. We will consider this one as vulnerability index. So the data, the field name will be vulnerability index, data type will be double, and click OK. So how we can calculate the vulnerability index? We consider vulnerability index equals population density. So we will click over there, click on field calculator. Now what is the, how we can calculate the vulnerability index? So the population density, population divided by GND area, and now I can click OK. So now I do have this vulnerability index. So actually it is the population density. Here we consider it as the population density. Okay, now I can keep this file aside, and now I will go with the next data set. For the next data set, what we need to do is we have to generate the 4 criteria for the rasters. So here we will score the rasters from 1 to 9 each for 4 constraints. So first we will focus on the roads. So I will load the roads layer from here. I will click on roads. I will add total roads layer into the map. From there, I just need to focus only on the main roads. Instead of the minor roads, I will focus on main roads. So how we can select the main roads? We can right click on the roads layer and then click on open attribute table. Then I can select attribute, and then from here I can say f class equals and then get unique values. So I will consider as the primary routes, and also O I will consider F class residential. O I will consider F class equals secondary. So I will consider these three road segments for the main roads. Before we do this one, we need to consider these classes, and then I will click apply. Now you will select, see, all the layers were selected based on the primary, then residential and the secondary. So I will click close from here, and then what I have to do is I have to clip this data file into the Ratnapura district. So for this one, I will open up the district shapefile and drag it here and drop. And from the districts, I will open up the attribute table, and then I will click on the Ratnapura district from here. And then now I will go into the clip tool. After selecting these two features, I will go into search and then search for clip analysis. Input features will be roads, clip for the district which is selected by Ratnapura. So this one will be roads of Ratnapura district. So I will click OK. Now what should I end with? I should end up with the roads in the Ratnapura district. So if I remove this layer, now you will see all the primary roads, secondary roads and the residential roads in the Ratnapura district. So these are the roads that anyone can access. So after that I will remove the roads layer. Now what I have to do is I need to convert this roads layer into the same coordinate system. Right now if I go over there and like see, the coordinate system is in geographic coordinate system, not in the projected coordinate system. So how I can do the projection? I can click search for project from here, define projection, define projection. It should be project. Define projection is used when there is no any coordinate system, but you need to assign a coordinate system. We will use the define coordinate system. So in here I will click roads Ratnapura and then roads Ratnapura district projected to the Kandhavala Sri Lanka grid and click OK. So now I will remove this layer as well. Now I ended up with the roads layer, and now what I need to do is I need to view the values. So values will be, if the road, we will create multiple ring buffers, one at 50 meters, another one at 100 meters, another one at 200 meters. So if it is like closer, that means it's much better. So if it is 50 meters, then it's much better. So now what we need to do is we need to go for the search for the tool called multiple ring buffer. Then we need to do the buffering. For the input tool, we will select input features, we will select road Ratnapura district, which is already projected, and then this one will be like projected buffered. Now I will add the distances. First distance will be 50, the second distance will be 100, third distance will be 200. So from here, buffer unit, I will prefer it as in meters, and then dissolve optional, I will select all and then click OK. So it will take some time to buffer. Just give it some time. Let the buffering finish. At meters, or for the processing extent, I will select Ratnapura GND for projected. Click OK and click OK. Maybe the name is too long, that's why let me shorten up the name. Roads buffer as 50, then 100, then 200. When it should be in meters. Click. Let me dissolve this one first. I will dissolve the whole network first, because I think we have like too many polygons over there. I will click on this one and then click dissolve, roads, dissolved, and then click OK. So now I do have the road dissolved layer. So I will remove this projected one. Now I will go with multiple ring buffer. From there I will click input features, road dissolved, roads, buffered, distances will be 50, add, then 100, add, then 200, add, distance will be in meters, and then click OK. So after buffering finish, what we have to do is we need to assign the scores. After assigning the scores, we can convert this shape file or the vector file into a raster file. So we have to do the same thing. Then we have to go with the landslides, and then we have to go with the slope. If you are planning to like land as a helicopter or something in an emergency situation, the slope should be like less than 5 degrees. So we need to calculate the slope from the dim and then get the slope or the angle, and then we will go with the land use suitability as well. Let me export this one in somewhere. For dissolved, instead of putting this one into the geo database, I will put this one in the practical 4 food directory. I will type this one as roads buffered.shp. Then the distance will be 50. I make a mistake. I make a mistake. Let me run the tool again. Road dissolved, and then save this one as road buffered. Replace. I will remove this one, and then I will remove this road buffered layer. Yes. Now I should be able to find this one over there. without any issue. I will get 50, then 100, and then 200. The buffering unit should be meters, distance, and then click OK. So you have to keep in your mind when you are running the multiple ring buffer tool, you cannot save this one in a geodatabase file. Instead, you have to save this one in a folder or specific directory as .shp file. Okay, I think multiple ring buffer is giving me some issues. I don't know what's the problem. It should run without any problem. Here is giving me a video. So what I will do is I will create buffers, separate buffers. So road is old. This one will be 50 meter. So linear unit is 50. Area is in meters, and then round planner, dissolve type, wall, and click OK. Okay, now the 50 meter buffer is there. I will create another buffer. This time road dissolved, same thing. This one is 100 meter, and then linear unit is 100 meters. So all click. So what it is actually doing is creating these buffering zones. Last time I show you guys when I am doing that river buffering how it's actually working. So if I pull this one down, you will see 50 meter buffer in the blue color, and then the 100 meter buffer in the greenish color. So another buffer I need to add for this dissolved layer. This one should be 200 meters. Meters dissolve type or click OK. Okay, now you can see these three buffer zones. So now what I have to do is I have to merge these buffers together. I will search for merge tool. Fifty meters, then 100 meters, and then 200 meters, and then this one will be road multi buffer. I will click OK. I will remove these layers. Now what I have to do is I have to open up this multi buffer layer, and then this is the shape file. So if it is closer, region is closer, that means it should be a good place for a disaster relief center because it is easy to access. So now I need to give a marking range of this one, because for that thing I will create a field named score. It will be short engineer, and then I will click OK. Now I have to add the scores. So to add the scores, I can right click on this road multi buffer layer, edit features, and click on start editing. Then click OK. Now for this 50-meter buffer, the closest one, I should give the highest value as 9. So if it is 50 meter, it should be 9, then 100 meters, it should be 7, and then it's 200, it should be 5. So this is for the 200 meter. I give the value 7, and for the 200 meters, I will give the value 5, and then I will right click over there. If you didn't see this editor toolbar, you can right click and click on editor, then you will see this toolbar. So if you didn't see this one, you can right click on editor, and after that click on editor, save edits, and deselect this one. Now I am going to convert that uh, vector file into a raster file. So I can type feature to raster. So feature to raster, road dissolved, road multi buffer, and then based on the scores, convert this one into the layer called roads situation. So road situation file, and then output cell size, I can type output cell size as 10, because all the other files, that means the dim and the uh, dim, and then the other file, that means the classification file which we downloaded from Sentinel 2, is also in 10-meter resolution, and click OK. This saying is logged by another process, that means I didn't stop the editing. Then I can click OK. By saying the dataset is already exist, click here, remove those road creation file and click OK. Beautiful. Now we do have a raster. So I will remove this road multi-buffer and road dissolved as well. So now we created the first layer for the site selection, road buffer layer based on 50 meters, 100 meters and 200 meters. Next one is we have to do the preparation for landslides. So landslide should be at least 1 kilometer away. So we will divide this one into like 1 kilometer away, then 2 kilometer away, 5 kilometer away. So further away is much better. So if it is between 1 kilometer to 2 kilometer, we can assign 5, and if it is between 2 kilometers to 5 kilometers, we can assign 7, and if it is away from 5 kilometers, we can say it is 9. So you got the idea. Now I will load the data set, the landslide locations, previous landslides. I will add them into the map. So you can see these points are there. If you click, you will see the information. Just click info, then click on the button, you will see the items. Now I will go to the districts file, open the attribute table, click on Ratnapura District. Now I have to clip the landslides which happened in the Ratnapura district. So go to the search for clip, analysis, input features is like previous landslides, clipping feature is district which were within the Ratnapura district. Then I can say landslides, landslide location clipped. Click OK. Then I will remove these all the other landslide location files. So if I click over there and open the attribute table, I will see how many landslides happened previously. 1, 2, 3, 4, 5 landslides were there. Now the next thing is we need to convert this same layer into projected coordinate system. So how we can do is we can search for projection, then project, the data management. We can click location clipped, project this one into the Andhra Sri Lanka grid and click OK, and then this one will be landslide location clipped. So after that we can remove this one. Now we need to do the buffering. So what we have to do is we need to create 3 buffers, one for 1 kilometer, then 2 kilometer and then 5 kilometer. After that what we have to do is we need to isolate code rings using the erase tool. So let's create the buffering. So we have to search for the buffer tool, analysis, and then click on the clipped project, and then this one will be landslides within 1 kilometer, linear unit 1, decimal degrees. I can click on kilometers, this all type I can click on all, and then click OK. So these are the 1 kilometer buffer zones. Then I will click on buffer again, select the landslide clipped, and then give it a name as landslide which will happen in 2 kilometers. Linear unit is 2, then in kilometers, then dissolve all, click OK. we do have 2 kilometer radius. Now we have to search for 5 kilometer. We will create the buffer for 5 kilometers as well. 5 kilometers. 5. These all click OK. So now we do have these 5 buffer zones. Now what we need to do is we need to say away, not within. We have to find away. So we have to get the range 1 kilometer, 2 kilometer, and then 2 kilometer, 5 kilometer, and then farther away from 5 kilometers. So how we can do this calculation? I will remove this location point data set. So now what we need to do is we need to search for the erase tool and then subtract from 2 kilometers to 5 kilometers. That means it will be the data in the between 5 to 2 kilometers. So now I have to search for erase tool in analysis, and then the input feature will be 5 kilometer, and then erase feature will be 2 kilometer. From this one what I can get the distance between the area of from 2 to 5 kilometers. So this one will be landslides 2 to 5. We will click OK. Now you see 2 to 5 kilometers radius is there. I will click erase again. Analysis tool. Now this time I will select 2 minus 1. That means landslides which will happen from between 1 to 2 kilometers distance. Then I have to do the final erase. For this one I will select input feature as Ratnapura GND population, and then from here I will select 5 kilometers. This one will be landslide above 5 kilometers. So for this GND5 I will do the this whole part only for the landslide above 5. This whole click. So now I do have these regions. So I will remove this one. So now I will remove these landslides buffers. Only keep this distance. Now I have to merge them together using the merge tool. Data management, add 1 to 2, and then 2 to 5, and then above 5. So this one I can say landslide buffers. Click OK. After that file is created, I can delete these 3 layers, and then right click on here, click on open attribute tables. Same thing goes here. So if it is between 1 to 2 kilometers, we say it is a good score. So I will type the score in here as well. Short integer OK. If it is the distance is shorter, now I need to edit this one. Right click, edit features, start editing, click on continue. Then if it is between 1 to 2 kilometers, is not that great because previously a landslide happened on that location. So it should be farther away. So less, we will type 5, and then between 2 to 5 kilometers we will say moderately, that means 7. Then farther away from 5 kilometers we can say 9. Then after that go into the editor, click save edits, stop editing. Now we need to convert this one into a raster. So search this one, feature to raster. Now I will convert these landslide buffers based on this course, and this one I will rename the data as landslides recreation. So cell size 10, click OK. Why we go with the cell size 10 is because we do have the land use land cover classification data which was in 10 meter resolution. That's why we type 10 over there. Okay, now we do have this buffering part as well, and then we have to go with the slope suitability. So here also we will do the categorization. If the slope is between 0 to 9, that means lower the angle is much better, that means the area is flattened, and then we can go up to 5 degrees. So we can say 0 to 2, 2 to 4, and then between 4 to 5. So I will go back to the catalog and load the dem file in here. Now what I have to do is I have to clip this one into the Ratnapura district. So I will right click and open the attribute table of the district file, search for Ratnapura district, and now I will do the clipping. Search tool, I will search for the tool clip raster. Clip data management, dem, output extension, I will say district, use input features, maintain clipping, and then save this one as dem clip. So now I have a nice clean cut dem file. I will remove this one. Now same thing goes here. If we go to the properties, we need to do the conversion into the Andavala coordinate system. Same thing. So how we can do the projection? Project, search for project. Under the for this one we have to search for the project raster, and then click on dem clip projected raster output coordinate system Andhra Sri Lanka. Okay, I will say same size 10. And now it has been projected. So if I go into the properties of the projected raster, you will see it has been converted into Kandhavala Sri Lanka grid system. Now I need to convert this one into slope. So we can search for slope under the spatial analysis, Then for the input raster we can feed the dim, and then this one we can say slope Ratnapura in degrees of course, and click OK. It will take a while to calculate the slope. Okay, now we do have the slope file like this. Wait, now we need to do the classification. We have to reclassify. So if the values are ranging between 1 to 2, it's higher, that means okay, 9. Then if it is 2 to 4, lower, value is 5. And then if it is between 4 to 5, it's 5. And if it is above 5, those locations are not suitable. So now search for the tool called reclassify. So reclassify under this partial analysis. Click on the reclassify under partial analysis, load the slope Ratnapura, and then click on this classify icon. So how many classes we need to have? 1 to 2, that means first class, then 2 to 4 second class, then 4 to 5 third class, and then above 4 class 5 classes. So I will click on 4. So the break values will be, first break value will be 2, the next break value will be 4, and then the next break value will be 5, and the maximum value will be this by default value. I will click OK. Now 0 to 2 we have to give the value, that means the higher slope, then it should be 9. Then between 2 to 4 it will be moderate 7. Then 4 to 5 it will be 5, and if it is above that we have to type it as no data. I will copy it from the below data file and click OK. Now this one should be the slope equation raster, and then click. Now I can remove this one. I will see a raster like this where the 2 degrees angles like the locations and the other locations. Don't worry, because if you see the water surface, that means it's totally flat. Those surfaces are like very suitable, but the problem is we cannot land aircraft or something into those regions. Okay, now we create the slope equation as well. For the last one we will have to use the land suitability equation. So for this one I will go back to the catalog and then load the LULC file, that means the classification file, and load into the dataset. Don't worry when you see something like this, I will give you the file. So this is the land use land cover file. I will put this one over there. So if you see 1, that means water, 2 trees, then 4 flooded vegetation, 5 crops, 7 build up areas, 8 bare grounds, 10 clouds, and then 11 ranger lands. So now what I have to do, simply I have to do the reclassification. So I have to do a reclassification. So if the value is bare land, then I have to give it is as 9. So we don't have scrub in here, so I will remove this part. We don't have that file in here. All other classes we can assign as no. So now I will go and then do that thing. So how we can do the reclassify? Search tool, search for reclassify spatial analysis, input the raster classification based on the values, then classify. It's okay, keep these values, and then this one will be the LULC sequation raster. Then for the value bare ground, the bare lands, what's the value? Number 8. So if I see number 8 on all values, keep that value and replace all the other values with no data, except number 8, replace all the values, other values with no data. So I will replace it with no data. So here I see 8. If I see 8, it should be 9, and the other value should be no data. And then for additional case, I will say rangelands. So rangelands also we can consider as locations where we can land uh, flights. Instead, I will say type no data. Only I will consider the bare lands, and then I can click. So now if I remove this one, you will see only the bare lands. You cannot see actually. Bare lands are not all around the place. No, in some places you will see the bare lands. Now we do have these 4 equation files. Now we need to go with the suitability heat map using the weighted overlay. We have to find the tool called weighted overlay. We can go over there and search for weighted overlay. So here I did made a mistake. I need to do the clipping part and then conversion part. So I will clip the LULC equation as well for the district. We open the attribute table, Ratnapura District, and search for clip. Since this is raster, we have to go with clip data management, and then click on LULC equation, output range, districts. Okay. After that, I will remove this one, and then now I have to do the conversion from WGS to Kandapur. So it will be projection. So I will go with the define projection on define projection. Go with project raster. This is raster file equation, and then Kandapur grid. Okay. So here output cell size same as road 10 by 10. Click and click OK. Now we will remove this file as well. Keep only these 4 files: road creation, landslide creation, slope, and then projected LULC equation. So these all the files should be in the same coordinate system as Kandapur. You can verify by going to the properties and see the coordinate system. This one is also should be in on the other green. I will remove this district file, I don't need it anymore. So now we will do the weighted overlay. So copy and then search for the tool called weighted overlay, spatial analysis, and now load the rasters. LULCC equation values, okay. Then the second one, slopes equation values, okay, and then side roads equation, and then finally landslide equation. So here I will select equal values, so it will weightly 25%, 25%. So you can decide. So if you consider one factor more, then you can like adjust it, but altogether it should be accounted for 100. And then evaluate scale by 1 to 9 by 1, and then this one will be the data layer we can say as suitability heat map dot div, and then click OK. So now we need to do this Gaussian selection. So here you cannot see because those points are like very smaller. So now we need to convert this suitability heat map into points. So how we can like convert this one? We need to do raster calculation. So we will get the raster calculator, raster, search for raster calculator, and then type this function. So you can either copy and paste this one, or you can type condition suitability heat map dot if greater than or equal 8, and reclassify it as 1. So condition suitability heat map greater than or equal 8, after the comma it should be 1. In output raster we can say sites with vulnerability. I will say this one as candidate locations, then click OK. So now what I can do, I can convert this one into a raster to polygon. Input candidate location based on values. I click OK. And now I will convert this one into feature to point. The data management raster T candidate polygon. This one will be the candidate sites. point layer, click. Now we will have point for a suitable side. So here I only have one side which is much more suitable for this landslide management, if you are going to focus on landslide management. So how we can increase these locations? So that's another problem. So if you need to increase the locations, how we can do that thing? We need to increase the location suitability. If we increase the location suitability, then we can increase the number of points as well. So how we can do that? I will load the classification file again. From there, now I will do reclassify. Partial analysis, load the classification tip based on the values. 8. This time I will give the value. If it is 11, I will give the value 7. And then if it is 10, no data. If it is 8, 9. All the rest of the classes I will say no data. So 11 is range length. For this one also I will give 9. I will consider those range lengths as LULC recreation as well. LULC R, click OK. I will remove this one. So that what I can do is I can do the same thing. Now I have to do the clipping part and then I have to do the projection part. So I will do the projection first in here. Project raster. Coordinate system. Kandawala. So here the grid will be by 10. Same. Okay. Now I will do the clipping part. Projected raster output extend to Ratnapura GND. Good features. You will see creation 2 and click. Remove this one as well. So I have like another more location. So now I can do the weighted overlay. Again. I will add this time LULCC2 raster. Then I will add LUL slope equation. then landslide equation, then odds equation equal 20 by 25. This one will be weighted for LULC 2. I will click OK. Now I do have like more suitable locations. Now I will do the raster calculation again. So condition weighted LULC greater than or equal 8, comma 1, output raster 8 LULC filter. Okay. So now click on raster to polygon. LULC then feature to point. So now you see I do have a lot of potential candidate sites. Here. So now we need to do the calculation. So if the population is higher, then select the best location. So how we can do that filtration? Let me type, otherwise in here you will be in trouble. So here type pair land and ranger land as 9. Put the ranger land also to the class 9 and all the others into no data. Now final selection is partial join and selection. So how we can do the selection? Identify export. So now we have to do the partial join. So for this partial join, how we can do? We will go for this partial join. Analysis. So this time target feature will be LULC points, join feature will be Ratnapura population projected and join 1 to 1, and then from here we have to select intersect, join 1 to 1, intersect, and then sites with vulnerability. Click OK. So now if I open the attribute table and go over there to the vulnerability index and filter, now this point is highly vulnerable. So it is in which GND, Kodigamo GND, and then Udumata GND, then Yodagama GND. So we can do a simple thing, we can dissolve. So I will dissolve this one to find the best three positions. I will do the dissolve. I don't need to do the dissolve. From here you can select for which GND, Godigattagamuwa, Udumatta, and then Yodagama. So these locations are highly susceptible for the floods. So if we see, okay, this even like near to the roads, and then if we go with the landslide situation, it's like further away from the previously occurred landslides. No any landslide nearby these locations. So even for the first one, it's also farther away from previously occurred landslides, nearby location, and then Yodagama, and then Godagamu. So Godagamu is over there, but is in a safer location. So if we need a location where previously landslide happened, but we need to allocate, this is also a better place. Now you can output these three locations, and then even you can display this, visualize this map as well, suitability map. So if you zoom in, you will see the suitability part as well. For a specific location, if you zoom in, you will see 6. So higher the value, that means is okay. If you see green color, that means those locations have the potentiality. So you can like overlay this map into a Google Earth engine or Google Earth Pro after exporting this one into a KML file and visually inspect which location is much more suitable with the historical images. Now you can like create the layout for this weighted LULC and for these three locations. So that's it. I hope that you guys understand this session, and I will see you and like hope you all the best for wish you all the best for your upcoming examination.